Hi everyone, welcome. My name is Lyle Tavernier and I'm speaking to you from NASA's Jet Propulsion Laboratory in Southern California. We're excited to talk to you today about climate science and answer your questions. Before we get started, what I want to do is introduce our other guest, and I'll let Brandon introduce himself.
Hi, how's it going, everyone? My name is Brandon Rodriguez. I also work in the education office at the Jet Propulsion Lab with my good buddy Lau.
Great, thanks a lot. So we're going to be answering questions today about climate science, and some of you might be thinking, well, we know that NASA goes to Mars. We know that NASA um, sends rovers. In fact, we've got one on its way to Mars coming up soon. And one thing that we one thing that we also study is Earth, and that's not something that a lot of people think about. And so I'm going to let Brandon explain a little bit about how we do that.
Yeah, I feel like a lot of attention, especially with the Perseverance rover coming up, goes to the exploration of Mars. And we really want students to focus on all of the really exciting research taking place on exploring Earth. Um, I maybe we don't think about Earth as being unexplored. Maybe we think of Earth as already having been explored, but that's not really quite true. Our Earth is an amazing place with huge oceans that we've only seen a tiny fraction of, and we're discovering new life all the time. Um, and when we think about how important this is for the health of our planet as we explore and find out new things every day, one has to ask ourselves, well, maybe we need to make sure we take care of this place. So as a result, NASA does a lot of really cool research from space by sending over a dozen active satellites now looking downward, looking at our oceans, looking at temperatures, looking at clouds. All of these things are really, really important to be able to understand how our Earth is doing and what effect we're having on it. So we hope that answering some of your questions today will kind of give you guys a feel for what it is that we can do to protect our planet, to understand our planet better, and ensure that it stays happy and healthy going forward.
Yeah, so if you take a look at the screen right now, what you'll see are animations of many of the satellites that are orbiting Earth. And as Brandon mentioned, there are lots of them, and they're studying a lot of different things. One satellite that was recently sent into space was the Sentinel-6, which you can see here. This is the most recent Earth satellite, and it is uh, measuring sea level, and it actually has a number of different instruments that will allow it to not only measure sea level, but also give us additional information about the weather.
Yeah, I think when we think of something like Sentinel-6, this is the continuation of several satellites that have already been looking at sea level rise and weather, and it's kind of like the next step. That's I think what's really interesting about climate science is that we get better and better at understanding trends. Technology gets better, so we can do more and more. I know that some of the recent science looking at things like greenhouse gas emissions and the level of CO2 in the atmosphere. These things, for me as a chemist, I think about are really important. So we can look at how gas levels in the atmosphere have changed over time. But obviously, we haven't been able to send satellites into space for very long. So how do you measure something on a real long time scale before we even had the technology to do so? Well, we go back. We look at sediment in the ocean. We look at ice core samples, and we look at gases that are dissolved inside those, and it kind of gives us a picture of ancient history. And this allows us to get data of what our climate looked like, not just in the time of humans, but even hundreds of thousands of years before that. So we can look literally a million years in the past looking at these samples and see what effects we've had as people, creating these greenhouse gases and kind of altering our planet's atmosphere.
One thing that I think is pretty interesting is you're talking about all this data that we have. This is data that we can access that's publicly available. Students can actually go online. I'm going to put up a site here. This is a website called climate.nasa.gov. And if you take a look at this website and scroll down a little, let me put the URL up on the page so that you'll be able to see it as well. If you look at this page, you can look at things like evidence of climate change, causes of climate change, the effects of climate change, and even ideas and suggestions for solutions to climate change. So there's a lot of information out there that you can actually take a look at and be good stewards of data and look at what we have measured from space as well as from Earth. So I think that's a pretty great site to find information for yourself and learn more about climate science.
Yeah, and certainly Lyle and I both, as former teachers, really like this website because you guys can pull up this data, interact with it. You can download the data that we have from these satellites and actually, put it in, your computer software. You can take a look at trends. You can see these animations from over time. So it's a really great resource for you as students, as teachers, kids at home. What do you think, Lyle? Should we jump into some questions?
Yeah, that sounds great.
So we got a lot of really great questions from students. Thank you guys so much for submitting these online to us. We're really excited about this. So one of the questions I saw that I really liked is, why is it that we need to measure temperature and humidity, and how is it that we actually measure it from space? So we have all these satellites, but how is it that they're actually performing the science from so far away?
Yeah, so that's a really great question. One of the reasons that we study and measure things from space is because we can cover or measure the entire globe in just a matter of days. So rather than going outside and measuring one spot with a thermometer, or going to the beach and measuring sea level in one spot, we can get global coverage for some of these measures in just a matter of days, which 100 years ago was simply something that was not possible. And so being able to study from space is really important. But not only the why do we study from space, but why do we want that information is important too. When we look at sea level over time, we can see trends in the level of the ocean. When we look at temperature over time, we can see trends in temperature over time. So we want to be able to look at global temperatures, global sea level, to get an idea of not just what's happening in one particular spot, but also what's happening all around. And so I think that's one of the important ways that we, or one of the important reasons, I should say, that we measure from space.
Yeah, I think Lyle really makes a great point. It's helpful, and still many scientists do take kind of local measurements, and that does help. But when you want a picture of the Earth as a whole, and the Earth is so big that when you want to look at trends, you really need to not get hung up in just what you see around you. And this plays a lot with a question that we always get asked, which is being able to differentiate, be able to tell the difference between weather and climate, right? So if you're looking at something nearby, if you're kind of saying like, oh, it rained today, or oh, it's been hot lately. These are single data points, right? But they don't give you a picture of the Earth as a whole and over the long time that these changes take place. So we really want to be able to understand the global picture and the picture over an Earth timescale. So we're very young as far as Earth is concerned. And Earth has had a long history of ups and downs and hots and colds, many ice ages. So to collect this data, we need to understand better on an Earth timescale, not on a person timescale.
Yeah, one of the things that I popped up on the screen just to show a little bit of difference here, you can see that weather includes things like temperature, precipitation, air pressure, wind, and humidity, whereas climate is really influenced by where you might be in the world. And so I think that's another important point to remember. So Brandon, do we have another question?
Yeah, absolutely. So Gabriella over at Fishing Cove Elementary is asking a little bit about Sentinel-6, which you mentioned. So you had said that this was the most recent one and was going to look at sea level, but can you tell us a little bit about how it's going to monitor sea level from space?
Absolutely. So as I mentioned, Sentinel-6 is orbiting Earth, and it gets a global coverage in about 3 days, which again is pretty fantastic. And the way that it does that is it has a radar that sends a signal from the spacecraft down to the ocean, and that signal bounces back to the spacecraft. And it does it very quickly. But we measure how long it takes for that signal to go down to the ocean and then back up. And by doing that, we can calculate the distance that that signal traveled, and it tells us the height of the ocean in that spot. Now, it's taking hundreds of measurements per second, and over the course of 3 days, we can get measurements that are accurate down to the centimeter across the planet, and that's pretty impressive. But it also does something else. It uses GPS satellites. Think about the GPS satellites that you might use, or probably not you, because you're probably not old enough to drive, but maybe you are. The GPS satellites that we use for navigation and getting around, those are orbiting around Earth, and as they go beneath or below the horizon from the perspective of Sentinel-6, the satellite is receiving those signals, and as they get bent around the edge of the horizon, those signals change a little bit. And we can use those changes in the signal to understand things about or measure the humidity and temperature of the atmosphere. And so not only are we measuring sea level with Sentinel-6, we're also getting data that can help us with weather forecasting and climate modeling, which I think is pretty fantastic.
Yeah, it's pretty wild to think, just again, as I kind of mentioned earlier, how technology keeps evolving. So with all of these satellites up, this fleet of Earth science satellites, they're all kind of helping each other out, and that data comes together to give us a better scientific picture, right? If you think about a good scientist doesn't just measure one thing, they want to measure a lot of different things and see how those pieces fit together. So when you look at things like sea level rise and greenhouse gases and global temperature, those are three very different measurements that kind of paint the picture of the effects of climate change. These are how scientists are able to tell that climate change is definitively real, right? It's not just one thing, one measurement in one area. This is a global picture using different techniques to really kind of make a full scientific picture.
Yeah, I think that's a really important point is we're not just taking these single measurements from the ground. We're not even taking them from single measurements from one satellite. We're looking at lots and lots of data. And not only are we taking data from satellite, we're comparing it with what we measure on the ground to make sure that what we're measuring is accurate. And we call that ground truthing, which is another important point or another important step for scientists, is that they're ground truthing and verifying the data that they're collecting. So that was a really great question that I think allowed us to answer a lot of different things. So Brandon, let's check in on some more questions.
Yeah, I got a really good question here asking how far down can satellites measure into the surface? So we've talked a lot about oceans, but what about like subsurface? Can we see underneath the water? Can we see into the land? Things like soil moisture or anything like that?
Oh, that's a great question. So different satellites, again, are measuring different things. And we can measure soil moisture down to a few centimeters with missions like the SMAP, or Soil Moisture Active Passive Mission. We can also measure sea surface salinity by measuring the top several centimeters of the ocean. And while you might think that the top several centimeters isn't enough to tell us about the salinity or the saltiness of the ocean, by understanding what the top few centimeters are like, we can then understand or infer and interpolate what those depths below that mean. So there are lots and lots of ways that we can measure, lots of things that we measure, and yeah, we can actually measure below just the absolute top surface.
Yeah, I've always been really interested in this from just being kind of a nerdy chemist type. When I think about measuring ocean temperatures and ocean salinity, I know a lot of us love the ocean and we think about all the just really cool and exciting wildlife that lives there in our oceans. And, you know, I think we talk a little too much about how climate change affects us, right? We just think about it from a very kind of selfish perspective. It's hot for me. Um, well, think about how this affects a planet that's covered in over 70% water. What does that mean for marine mammals and life in the ocean that um, is kind of feeling the consequences of all of that heat first? They're feeling it much more than we are as people because water absorbs heat so well. And because of all this, as the planet gets warmer, our oceans are absorbing that heat for us and getting hotter faster. Um, and that means that water is getting warmer deeper. So animals that might swim closer to the top are being moved, across the ocean to places they normally wouldn't be. Um, these types of effects, are something we really want to be, cognizant of. We want to be considerate of other life on our planet.
Yeah, the point you make about the ocean being able to absorb a lot of heat is pretty important. And there's actually an activity that students can do. I'm going to put a link up on the screen now. If you go to our Learning Space site, there's an activity about what's called thermal expansion, and it's a good opportunity to learn about water absorbing heat and what happens when it does that. So I'll leave this up on the screen for just a few more seconds, but that's our Learning Space site that you'll want to check out.
We got a couple questions about climate change and what we can do in English and in Spanish. So, ¿cuánto tiempo se estima que tiene la Tierra para resistir el calentamiento global? I'll take first stab. La respuesta es que la Tierra ya está en peligro. Es importante que todos comenzamos a hacer pequeños cambios ahora. If we start to make small changes now, we can really start to undo some of the damage that's already been done. And when students ask, what can we do? We're relying on you. You're the next generation, and we have hope that for every little change you make, it'll compound, it'll add up. So a bunch of people doing a little thing can really be a big thing. And if we can work together to make some of those small changes, I think we can start to see some impact and help protect our Earth. These changes are really, really small. I've seen some amazing solutions, even just in local schools. So you can work with your teachers on this. For example, I saw a school out in San Fernando Valley that instead of having disposable plasticware for lunches, they had a class set of plates and forks and spoons and stuff like this, and the kids washed them and it was kind of their class set. And this way they're creating that much less garbage that just goes into landfills. What a great idea. I saw another school that started their own garden and just kind of grew some vegetables there and just kind of, practiced caring about the earth and instead of just going out and eating fast food and having wrappers and throwing garbage away. So really, really small things you can do locally might really make a big impact. Lyle, I don't know if you have some solutions for us that we could partake in.
Yeah, I'd love to add on to that. I think it's really great that school is doing that with the reusable drinkware and dinnerware. There's actually a university here in Southern California, a couple of them, that have gone that step as well. So they've taken that same idea, and so going from even just maybe a few hundred students at an elementary school or a middle or a high school to thousands of students at a college and university. So you're seeing some of these bigger steps taken there too. One thing that you can do is you can take a look at what's called your carbon footprint. And your carbon footprint is something that will help you calculate how much carbon is being released into the atmosphere by your everyday activities. And that's things from how many trips are you taking in a car to go do something versus how long are you leaving lights on, or how much TV are you watching, or how many. There are lots of different things that are contributing to what's called your carbon footprint, and those are things that you can look up online. I'm going to put something up on the screen here, And if you take a look at this, this is kind of a way to look at solutions in two different ways. You'll see adaptation and mitigation. And what those things mean, mitigation is essentially what we're talking about, reducing the output of the carbon or the climate change causing gases, the greenhouse gases, reducing how much we're putting that into the atmosphere. And then the adaptation is what can we do to adapt to the things that have already happened. So temperatures have risen. The sea has risen. And so what are some things that we can do to adapt to those things? And so when we talk about temperature rising, one thing that we might think about is something like white rooftops. White rooftops reflect light back up rather than absorb them, and absorbing heat into buildings, which will require less energy. And so you're not only mitigating the effect, adapting to the effect of higher temperatures, you're mitigating the amount of greenhouse gases that you'd be putting out by having something that will reduce how much air conditioning you might need on a hot day. So those are two different ways that you can look at those different categories. I think that's a nice way to think about solutions.
We got a really great question here that I don't know the answer to, so I'm kind of excited to ask. We talked a lot about how the effects of climate change in ways that we know, like greenhouse gases and temperature. I'd never thought about this before, but I got a question from Nevia. Does climate change affect how thick the atmosphere is?
So one thing to think about when thinking about that question is the thickness of the atmosphere. If you wave your hands like this, you can actually feel the atmosphere hitting you. And it's not something that we usually think about when we feel that, but that is in fact the atmosphere. That's the nitrogen and the oxygen and the carbon dioxide and all those things in the atmosphere that are hitting us in the face. When we go higher in altitude or elevation, depending on if we're in an airplane or climbing a mountain, the density or the thickness of the atmosphere will reduce. And so there are natural reductions in the thickness of the atmosphere. But when you also think about gases, again, the atmosphere is lots and lots of gases. It's a mixture of gases. Gases will expand when they heat. And so there is, in sort of a broad sense, with an increase in global temperatures, there is an expansion an expansion of the volume that air would take up. I don't know that it's huge. I don't think we're necessarily worried that the atmosphere is going to expand so much that we have to send satellites further out into space or further away from the surface of the Earth to get them into space. But expansion of gases is something that in fact happens when they heat up, and the same goes for the condensing of those gases when they get cold. So I don't know. Hopefully that answers your question. That's a good question. I hadn't thought about that either, and that's kind of the cool thing about talking to students is they've got all these questions that maybe we don't know the answer to, and it's very possible that the answer is out there. But it's also possible that you've got questions that maybe we don't have the answer to, and that as you go through your high school and college careers, you can start investigating some of these questions and finding the answers to them and becoming scientists in answering some of these questions.
Yeah, I think Lyle and I can both agree that the easiest way to get stumped on a question is to ask a young student. You guys have the best questions by far. So maybe two more quick questions looking towards the future here. I got a really good question about space debris, and is that something that we need to worry about for the future? I know that it's more than just a couple old satellites that are kind of whizzing around, but when we think about not just the safety of damaging our satellites, but things like the International Space Station, what does space debris kind of represent in terms of challenges going forward?
Yeah, so I guess we can think of space debris in a couple different ways. We've got satellites that are orbiting Earth that we're no longer using, and then we might have smaller pieces of debris that may have broken off of something. And that is definitely something that we need to keep in mind. Usually when we see maybe the International Space Station and one of the crew capsules docking with the International Space Station, it looks like they're approaching each other very, very slowly. And relative to each other, they are going very, very slowly. But they're both traveling at around 17,500 miles per hour. So when you're going in the same direction at 17,500 miles per hour, it's less dangerous than if you're going in opposite directions at 17,500 miles per hour. The example I like to give is if you've ever been in a car and you've had your hand out the window and a bug hit it, it stings a little bit. And maybe you're going 30 or 40 miles an hour with your hand out the window and get hit by a bug. Well, that bug's not very big, but you're going 50 miles an hour, that's going to hurt. If you're going 50 or 15,000 miles per hour, and it's not a bug, it's a bolt or a piece of metal from a satellite, that's going to cause some serious damage. And so we actually keep track of thousands of pieces of space debris. We know where they're at. We have an understanding of not only where they're at, but where they're going, and when they will hopefully, and as their orbit decays, burn up in the atmosphere. So we have to plan around those things. We need to make sure that we're not putting new spacecraft in a path that will damage them. The International Space Station actually gets boosted out of the way of space debris from time to time, so it is something that we keep track of, and it's definitely something that we are concerned about and need to make sure that we keep in mind as we're designing and operating spacecraft. It's also something that we've got rules about. We can't just create spacecraft that are going to make lots and lots of debris. So we've got agreements with other nations to make sure that we try to, again, mitigate these problems that we have up there. Great question.
Yeah, and just to kind of close out with the last question here, a lot of people are asking about, how technology gets better, asking about how things like our future missions are going to improve upon what we have. And for me, one of the exciting things that's in the works is NISAR, the next big mission coming up for Earth science. For me, I think this is really exciting because of the level of detail that it's going to collect. When we think about following ocean patterns, looking at water flow in rivers, being able to even detect, and kind of predict information around landslides, the amount of data that this is going to take is really exciting, not just from an Earth science point of view, but from kind of a computer science point of view as well. So that's a mission that is a collaboration between NASA and India, and that's something that I'm really excited about. So things are always getting better. Lyle, anything you're excited about upcoming for Earth science?
Well, I would agree that that mission is pretty exciting in the fact that, like you said, it's not just Earth science. It's going to take a lot of computer scientists to come up and develop ways to process all of that data that's coming in. So I think it's a great way to see the way that all of these different science and engineering and technology disciplines interact with each other. It's not just one person or a small group of scientists working on one particular thing. It's a lot of different people with expertise in a lot of different areas who can help each other out. It's not just one person who knows everything. It's a lot of people who know a lot of different things, and I think that's pretty important to keep in mind.
Yeah, totally agree. I think that's what makes science so fun, is that you get to work with other scientists with completely different expertise, and you always get better working together. That's one of the things I've enjoyed. So with that, I think we should probably close out. I want to thank all of you at home for dialing in and asking questions of us. I hope you guys enjoyed. This afternoon at 3 p.m. Pacific time, we'll be joined by Annie Richardson, a expert in the field here at JPL on some of these topics. So we're going to dive a little bit deeper into some of these satellites and technologies. Feel free to join if you'd like and ask more questions. And of course, stay tuned for all the exciting programming we have for entry, descent, and landing on the Perseverance rover. That will kick off this coming Thursday, which is January 14th. And tons of exciting programs as we get close to that landing in February. So thank you guys so much for joining. Really appreciate it, and hope to see you guys again soon.